Welcome to Brain Vision.
We need to find the value of m naught, and we also need to find the reactions at the points A and B. And I drew out 4 different free body diagrams to represent the different components in the given figure. So we have 2 diagrams for the 2 cogs and 2 diagrams for the 2 arms. So we're going to start working with this free body diagram, the cog FGH, and then use the information from this cog to help solve for m naught. So we'll start by saying that the sum of moments about the x-axis is equal to 0, and we can write that as the given moment 30 minus the force F times 30, the length 30 is equal to 0, and we can solve for F using that equation to get a force that is equal to 1,000 newtons. So next we're going to take the sum of moments about the point F, set it equal to 0, and we can write that as h of y times 300 minus F times 180 is equal to 0. And we can substitute in F since we just calculated that value. So we get that h of y times 300 minus 1000 times 180 is equal to 0. And we can solve for h of y to get a value that's equal to 600 newtons. And next we'll take the sum of forces in the y direction, set it equal to 0. And we can write that as f of y plus h of y minus f is equal to 0. And substituting in, we get that f of y plus h of y, which was 600, minus f, which is 1000, is equal to 0. And solving for f of y, we'll get a value of 400 newtons. So next we're going to work with the other cog. We're going to work with this free body diagram now and solve for m naught. So I'm going to write that the sum of forces, or the sum of moments, in the x direction is equal to 0, which you can write as m naught minus f times 90 is equal to 0, and we can substitute in f. Substitute in f, and we find that m naught is equal to 90 I Newton meters. And the I just tells us in what direction this moment is. So now for part B, we're going to take the sum of moments about the point C, set it equal to 0, and we can write that as negative e of y times 300 plus f times 180 is equal to 0. And we can plug in f to get negative e of y times 300 plus 1000 times 180 is equal to 0. And solving for e of y, we'll get a value of 600 newtons. So now we're going to take the sum of forces in the y direction, set it equal to 0, and we can write that as negative c of y minus e of y plus f is equal to 0. And we can plug in the known values and solve for c of y. So we have negative c of y minus 600 plus 1000 is equal to 0. And solving for c of y, we'll get a value that's equal to 400 newtons. So we're now going to focus on the arm ACF. So focus on this arm ACF. So using that arm, we're going to write that the sum of forces in the y direction is equal to 0. And we can write it as a of y minus f of y plus c of y is equal to 0. And we plug in f of y and c of y, and solving for a of y, we'll get a value of 0 newtons. So we conclude that the reaction force at point A is equal to 0 newtons. So now we're going to take the sum of moments, using the same free body diagram. We're going to take the sum of moments about the point X, set it equal to 0, and we can write it as the moment about A minus c of y times 200 plus f of y times 320 is equal to 0. And we plug in c of y, and we can plug in f of y. And solving for the moment about point A, we'll get a moment that is equal to negative 48i Newton meters. So now look at the last free body diagram, BEH, and solve for the reaction at the point B. So I'll write that the sum of forces in the y direction is equal to 0, which we can write as v of y minus h of y plus e of y is equal to 0. And we can substitute in h of y and e of y to get that v of y is equal to 0 newtons. So we can say that the reaction at the point B is equal to 0 newtons. And we're now going to solve for the moment at point B. So we say that the sum of moments about the x-axis is equal to 0. And we can write that the moment about point B minus e of y times 200 plus h of y times 320 is equal to 0. And after substituting in, we get that the moment about point B minus 600 times 200 plus 600 times 320 is equal to 0. And solving for the moment, we'll get a value that's equal to negative 72 Newton meters.